So this video is going to cover Chapter 4, Lesson 3. Chapter 4, Lesson 3 is now going to take us into equivalent ratios. Now we had talked about this prefix equal before, because we said we have equilateral triangles, we have equal amounts. We're talking about something that has an equal value in their ratios. All equivalent means is to have equal values. So when I look at this pie, no matter how many ways it's going to be divided, I have 1/2 the pie if this is the amount that I'm going to eat. Or we talk about, well, how much is left after the pitching. There's 1/2 of it left, or 1/2 of it was eaten. When I divide it into different groupings, then if I take that 1/2 and divide it in half, then I can see that, well, I would have 2 out of 4 total pieces, or 4 out of 8 total pieces. Well, what we're saying is this is still an equal amount. It has an equal value. So when I talk about ratios that are 1 to 2, or 2 to 4, or 4 to 8, then I still have an equal amount. Another scenario. Let's say during snack time you bring in a fruit by the foot. So you have 12 inches of fruit by the foot that you get to eat. But you had promised your buddy that the next time you brought it in that you're going to share with him. So you get to divide it in half. I would have 2 halves, therefore I still have the same amount as 1. But then you see that someone else didn't bring in their snack, so you decide with you and your buddy, well, let's share it with someone else. So there's going to be 3 of you, and I would have 3 equal pieces that I divided that in. I still have 3/3, which is still going to be the same as 1 whole. We could break that down into as many people we want to share that amongst. But if I talk about all the people that I break it into, then I'm still going to be talking about 1 whole fruit by the foot. Now, I know some of you are already talking, well, I'm not sharing my snack. Not the point of the lesson. The lesson is to understand what an equal amount is. Even if I share it amongst 9 different people, sure, it'd be a small piece, but 9 out of 9 pieces is still the same as 1 out of 1 or 1 whole. All of these fractions are equivalent ratios or equivalent fractions. Let's talk about these circles that we started with at the beginning. We looked at 1/2 and we divided it into 1/4, but that was saying that we have 2 out of those 4 pieces. Or if we divide it instead into 3/6, I'm still talking about an equivalent ratio or an equivalent amount of 1/2. And then the last one was 4/8. It's still saying that if I reduce that, I would still have a total of 1/2. Halloween's coming up. Let's say as you're dumping out your candy and counting, the dad says, well, hey, for every 3 Skittles you get, I'm going to get 1 Snickers. And so you start looking at what you have. And at first, when you first pull them out, I find 3 Skittles, but I have 1 Snickers. So dad says, give it here. And so he gets his 1 Snickers for driving you, trick-or-treating, because it's a very nice thing that parents do for you. But let's say you find out that you actually have 6 Skittles, and therefore you have 2 Snickers. Or that you have 9 Skittles, and therefore 3 Snickers. Or you have 12 to 4. So my ratios are going to be the same value, even though I have different numbers. So my grouping is getting larger, but I still am going to do it for every 3 Skittles, I have 1 Snickers. These are all equivalent ratios when I break them down. So as we're going through the questions, once again, be sure that you're writing down the information. Follow along with me. If you get a little confused, or as you're writing I go too fast, pause it, rewind it, rewatch it as many times as you need to where you understand the lesson. So when we start looking at this, it kind of looks overwhelming, but it's really not. You've seen this type of box since you were in little 3rd grade classes, because this is your multiplication table. So that shouldn't confuse you at all. We've seen this kind of set up for a couple chapters now, where we're just going to plug in the information. So don't let this stuff seem overwhelming, because it's really not designed to be overwhelming to you. It's designed to be a helpful aid that you can turn back in your book at any time to see this number chart. Or you can go to the front of your planner in the math references and have a number chart, and you can use it to help you solve some of these problems if you get a little confused on equivalent ratios. But this gives us the vocabulary word of equivalent ratios. It says ratios that name the same comparison are equivalent ratios. And all that means is ratios that name the same value. Because if I reduce them down, I would still get the same amount. So notice here we're talking about bags to apples. And when we're talking about bags to apples, then we're talking about for every one bag, so this is my number going across, and why it's blue, I would have 6 apples. And so my 6 apples is going across and it's blue. So I could then match those up. For every one bag, I have 6 apples. 2 bags, 12 apples. 3 bags, 18 apples. 4 up to 24. 5 to 30. So that's why a number chart, especially one in the front of your book that's larger, could help you with some of these problems if you get a little confused. But here's the math that we're talking about. If this was all blank, then we know that our original is 1 bag to 6 apples, meaning for every 1 bag that I buy, I have 6 apples in it. Then I could increase by 1 at the top. 1, 2, 3, 4, 5. I could go all the way up to 300 if I wanted to. But for every 1 bag that I increase by 6. So I know that I would multiply this by 2, and that would give me my 12. If I went to 3, 1 times 3 is 3, and if I went over 3, then I would have 6 times 3 would be 18. If I have 1 bag, and then when I talk about buying 4, then I'd take my 1 times 4, giving me my 4 bags, and then my 6, I know that I have 6 apples for every bag. 6 times 4 would give me my 24. So that's what this chart is helping us do, is just help us organize our information. So let's look at what the book is talking about. This is the ratio of adults to students on a field trip is 3 to 8. So they give you another number chart. Notice this one's bigger, so we could go out further and have larger answers and numbers, but they change the color for the 3 because that's the first part or the top part of our ratio, is that I'm having adults, I would have 3. So for every 3 adults that I have in my increments of 3, then I know my 8 students or my 8 children is going to change. So I can see that for my first 3 adults, I have 8 students. For my 6 adults, my second grouping, I would have 16 students. And we would continue out going forward. So it says to shade in the rows that show the original ratio, that's why they're blue. Think the original ratio is what? Shade in what rows? So my original ratio is 3 to 8. So I'm going to shade in my row for 3s for my adults, and I'm going to shade in my row for 8s for each of my groups of students. Then it says in step 2 to circle the column that shows the original ratio. That has been done. There is one group of 3 adults for every group of students, and that's why this is circled, because they match up. 3 would give me 8, 6 would give me 16. So let's just pick a random, let's say we have 6 groups of 3 adults. How many adults would that be? If there are 3 per group, and I have 6 groups, 3 per group and 6 groups, then I know I have 18 adults. And if there are 18 adults, well, then I had to take my 6 times my 8, which is how many students are per group, and I'd have 48 students. So that equivalent ratio would be 18 to 48. Step 3 says to circle 2 columns to show equivalent ratios. The column for 2 shows that there are 2 times 3. So we circled the second one in the book, and I have 2 groups of 3, which gives me my 6 adults. And when there are 2 times 8 then, so if I multiply my top number by 2, then I have to multiply my bottom number by 2, so I know I have 16 students. If I circled it just going forward to the next one, then I'm going to do the same thing. Now I'm going to have 3 groups. And I would have 3 times my 3, and I would get 9. And then I would take my 3 groups times 8 of each of the students, and I would get 24. So I would have 3 times 3 is 9 adults when there are 3 times 8, or 24 students. So we're saying that 6 16ths and 9 24ths are equivalent, equal value of 3/8. On this one then, it looks like we're comparing some kind of juices. So if we read the information, we can see that it says, Jessa made fruit punch by mixing 2 pints of orange juice with 5 pints of pineapple juice. To make more punch, she needs to mix orange juice and pineapple juice in the same ratio. Write 3 equivalent ratios for 2/5. So then we have this number chart that we're talking about, or our ratio chart. They give us this multiplication chart. Once again, it's a small version of what you would find in front of your planner in the math reference section. Hint, good place to look in case you struggle with any of these. So we're going to work through and we're going to figure out what these would represent. So I know that if I'm starting out, I have 2 orange juice and I have 5 pineapple juice if I grow in increments. And then they fill in some spaces here. So I know that I have a 15 here. I know I have an 8 here. So what are my equivalent ratios or equivalent amounts or values that we're talking about? Well, if I choose to just double my recipe, then I would be multiplying each by 2. And so my original ratio number, 2 times 2, would give me 4. And then I'd have 5 times 2, which gives me 10. So my ratio, if I doubled my recipe, would be 4 orange juice to 10 pineapple. Well, what if we have a bigger group and I want to triple it? I would multiply it by 3. So if I have my, well, that's 15 already there. Let's check that work. Is 3 times 5 15? It is. So I know that I'm multiplying by 3s. And if I multiply down here by 3, I have to multiply up there by 3. And if I multiply them both by 3, then I have my 5 times 3, which is 15, which they give me. But I do have my 2 times 3, which is indeed 6. And then this one goes to 8. It's already given. So I have to figure out, well, what am I multiplying 2 by to get 8? 2 times what? Well, 2 times 4. And they show me at the bottom, I'm multiplying the bottom by 4. So if I wasn't sure what I multiplied 8 by to get to, then I could look down here, and we know that if we have ratios, if we have fractions, I have to multiply my top and bottom by the same number. If I don't, then I don't have an equivalent amount. So I would multiply both by 4. That does give me 8, so that gives me my 20. So when we talk about equivalent ratios, then I just take these the way they're stacked, and I insert them as fractions over here on my answer line. So when we have 2/5 as my original ratio, then we're saying that 4/10, 6/15, and 8/20 are all equivalent, same value. On this one, it says to multiply or divide by a form of 1, write 2 equivalent ratios for 6/8. Now it doesn't give me my multiplication chart, it doesn't give me my ratio box, and it really doesn't tell me what I'm going to be multiplying about. It just says to write 2 equivalent ratios. Well, don't make this any harder than it needs to be. You get to choose what you're going to multiply by. As long as you're going to multiply correctly by the numerator and denominator by the same number, then you'll get an equivalent ratio. But we're also going to look at the next kind that was mentioned in the directions, which we haven't done yet. So let's say we're going to choose 5s. I want to multiply top and bottom by 5s. Doesn't matter, you can do any number that you want, as long as you multiply correctly. So 6 times 5 gives me 30, and 8 times 5 gives me 40. So I know that my equivalent ratio, when I multiply and put them in groups of 5s, then I multiply top and bottom by 5s, and I would have a ratio of 30 to 40. Now on this one, I can also divide. Now, in order to divide, they have to have a common factor. And we continue to get those mixed up between an LCM and a GCF. Remember that the LCM, least common multiple, tells me that I'm finding multiples of what we're talking about. This would be a multiple. 30s and 40s, I'm multiplying. Multiples mean to multiply. If I wanted a least common multiple, then I would have to figure out what's the smallest number between those two. But when I'm dividing, that's when I'm finding factors of. I'm finding individual numbers that will go into both parts evenly. So I have to figure out what it is that I can divide top and bottom by. They're both even. And we know that all even numbers can be divided equally by a 2. So I'm going to reduce by 2's. And honestly, is there anything else I can reduce it by? I could try 1's, but that wouldn't change it, and that doesn't give me an equivalent ratio. That gives me an equal ratio. So if I reduce by 2's then, 6 divided by 2 gives me, then 8 divided by 2 gives me, so I know my new ratio is going to be 3 to 4. So what we're saying is, then I take my answers and I put them on the number lines. So if I have 6 8's, then I know an equivalent ratio would be 30/40 and 3/4. So I can multiply or I can divide to find my equivalent ratios. So once we go through these, stay focused, stay with me, take your notes, write things down. This is how you're going to build that muscle memory on what we're doing in mathematics, but it's also going to help you make sure that you're really paying attention. Remember, not hearing me, listening to me, engaging your brain. And if you're engaged in your brain, you'll be writing your notes down and following along. So once again, we have these directions. Write 2 equivalent ratios. And once again, it's not telling us what we have to multiply by. It doesn't tell us what our denominator has to be. So we're going to go up here in this space, and that's where we're going to do our work. So if I start with 4/7 or 4/2/7, since it's a ratio, and I want to find equivalent ones, then you just pick whatever you want to multiply or divide by. Now if I look at reducing it to divide, well, there's nothing that will go into 4 and 7 evenly other than 1, and that wouldn't change my ratio at all. So I can't really reduce on this one, but I can multiply it by any number that I want. So let's just say we're going to start with 3's. So if I'm going to multiply by 3's to find an equivalent ratio, a ratio with the same value, then I know I'm going to multiply top and bottom by the same number. So when I multiply 4 by 3, and then I multiply 7 by 3, then I should get an equivalent ratio of 4 times 3 is 12, 7 times 3 is 21. So 12 to 21. Well, let's say that I want to multiply by 6's then. Same thing. I multiply top and bottom by the same number. Now, here's where some people have made mistakes in the past. I want to caution you on this. We don't ever go back to the previous ratio that we created. We're always going to go back to my original ratio, because that's going to give me a much larger math problem than I'm wanting to do. Okay, so if I focus in on just my original ratio of 4 to 7, then my math becomes a lot easier. So if I take 6 times 4, then that gives me my 24. And 6 times 7 gives me my 42. I'll repeat that again when we get into these boxes down here, because I don't want you to get messed up and get lost on what you're doing. But then I have to write them in the number lines. Now, someone asked me last week when we were in school, why am I so picky about writing an answer on the number line? Honestly, it's because if you don't do it on the I-step test, they don't count it as an answer. You can have all the work correct. Every step is shown. You have your answer and label floating out here where you worked your work. But if that answer is not on that answer line that they provide, they count it as a wrong answer. You get points for showing your work, but why miss a point that you should get? So I'm very picky about you writing your answers on the line. It's not all about the test, I promise. I really want you to understand how math works. But I also want you to get every point that you possibly can on every test that you take. Be it the NWEA, be it on I-step, or anything that you're going to take in junior high as well. And if they say it has to be on the answer line, that's why it's there. Well, let's write it there. So just make sure that your fractions are written on the answer lines. So then when I come down here, I don't have any information already filled in other than the one set, the one ratio. So once again, I'm just going to choose what I want to multiply or divide by. 3/7 can't be reduced any further than it is. Nothing will go into it evenly other than 1. That doesn't change my ratio. So I know on both of these answers I want to multiply. You get to choose what you multiply by. I'm going to choose 2 and 3. If you want to follow along and make sure that your answers are correct in your practice area, then go ahead and write 2 and 3. If you want to challenge yourself and do really big numbers and make it a little more difficult, then that's fine with me as well. But then I just fill in my box. I'm going to take 3 times 2, which gives me an answer, and 7 times 2, which gives me an answer. So when I do my 2's, then I know that I'm going to have 6/14. Because 3 times 2 is 6, and 7 times 2 is 14. So then I'm going to choose my 3's. Once again, don't multiply it by my previous answer. I'm always going to go back to my original ratio. My original ratio in this one is 3 to 7. That's what I'm multiplying by. So if I'm going to do equivalent ratios by 3's, then I would take my 3 times 3, which gives me 9, and 3 times 7, which is 21. So I'd have an answer of 9 to 21. On number 3, I have 5 to 2. Same situation. It can't be reduced. It wouldn't change it if I reduced by 1. So on both of these, I'm going to be multiplying. So if I multiply, then I'm going to choose to multiply by 4 and 5. If you want to do your different numbers, that's fine, as long as your math is correct. So I'm going to go, once again, I'm always going to start with my original ratio that is given. On this original ratio, I have 5 to 2. So I'm going to multiply my numerator. 5 times 4 is 20, and 2 times 4 is 8. So then I would have 20 to 8. When I go to my next one then, once again, going to go back to this original ratio each and every time. So 5 times 5, not 5 times 20, but 5 times 5 is going to give me my 25, and 5 times 2 is 10. So I'm going to have an equivalent ratio of 25 to 10. Now 4 looks a little different, and it's there to try to confuse you. But if you think I have to go smaller, because we are putting all of these numerically in order, then we're actually going to be doing what to get these? Now we're going to divide to get those. That's where I'm going to work backwards and have a smaller number. Well, there's only one number that can be divided evenly into 2 and 10 because they're both even. So I'm going to divide by 2's, or I'm going to reduce by 2's. And 2 divided by 2 gives me 1, and 10 divided by 2, 5. So I know an equivalent ratio to 2/10 is 1 to 5. So I'm going to go forward then, I'm going to multiply because I'm going to get larger as I go. So let's choose to multiply by 6's. I don't care what you multiply by as long as you do the multiplication correct. So if I take 2 times 6, I should get 12, and 10 times 6 should be 60. So I know an equivalent ratio is 12 to 60. Well, what about down here? They don't give me boxes. So I don't have to have boxes in order to do these? No, I don't. I just have to choose one I'm going to multiply or divide by to get my answer. So on number 5, I'm choosing to multiply by 2's and 3's again. So if I take my 4 to 5 and I multiply by 2's, then I would have 4 times 2, which is 8, and 5 times 2, which is 10, to give me a ratio of 8 to 10. And then when I did my 3's, I had 3 times 4, which is 12, and 3 times 5, which is 15. So two equivalent ratios that I could have are 8 to 10, 12 to 15. Now on these, any answer is possible as long as you did the math correct. So understand that when I'm grading it, I've got to see your work so I know where these answers came from, and I'm also going to be checking to make sure your work is correct. Not everyone's going to have the same answers, and I'm fine with that because that's the way it's set up. It can be any answer that you choose. On number 6, I have 12/30ths, so I'm going to actually divide for both of these. If I divide for both of those then, and I divide by 2's, and I divide by 3's. So in my numerator, I'd have 12 divided by 2, and 30 divided by 2. And then I'm going to go back to my ratio, and I'm going to divide by 3's. 12 divided by 3, 30 divided by 3. And that's going to give me my two ratios. Dividing by 2's or reducing by 2's, if we want to look at it that way, that would give me my 6. 12 divided by 2 is 6. 30 divided by 2 is 15. And then when I do by 3's, 12 divided by 3 is 4. 30 divided by 3 is 10. Equivalent ratios. Each of those are going to have the same value. And all I do to find them is by multiplying and dividing to make them bigger or make them smaller. So on number 8, once again, two equivalent ratios. It's up to you to choose your numbers. I'm going to choose 2 and 4. When I choose 2 and 4, then I go back to my original ratio every single time. If it helps you to circle your original ratios as you do these, then please do so you know what numbers it is that you're focused on. That will help some of you to remember to go back there instead of the numbers that you're going to create. So when I have my original ones and I'm going to multiply by 2's and then multiply by 4's and I work through them, then I have 9 times 2 is 18, 8 times 2 is 16, 9 times 4 is 36, 8 times 4 is 32. So I'm just going to multiply by the same top and bottom number, 2's and 4's. So on number 9, I'll work through this one with you. I am going to multiply by 3's and I'm going to multiply by 5's. So I'm going back once again, this original ratio, and I do my numerator and denominator by the same number. 5 times 3 is what? 15. And 4 times 3 is 12. Going back to my original ratio then, I'm going to do 5's. 5 times 5 is 25. And 5 times 4 is 20. So I should have 15 to 12 and 25 to 20. Now when I look at 6/9, notice I had these boxes at the beginning and boxes at the end. So I know I'm going to divide on these. I'm going to make it smaller so that they go in chronological order. So if I divide by 3 then, I take my 6 divided by 3, which gives me 2. And 9 divided by 3, which gives me 3. And go back to my original ratio to then do my next set. And this one I'm multiplying on. So I'd have 6 times 4, which is 24. And 9 times 4, which is 36. So my ratios are going to be equivalent one to another. They're going to have the same value, and I'm either going to divide or I'm going to multiply to get my answers. What about this one? This one's different than anything we've looked at up to this point. How do I find this information? Determine whether the ratios are equivalent. Whether, someone asked me about last week, how does that work in that sentence? Okay, so this is not W-E-A-T-H-E-R, storms outside, but whether, if it is or isn't. That's all it means. So when I have 2/3 and 8/12, now they're ratios, so it's actually 2 to 3 and 8 to 12. But some of you are going to find it much easier to just think about them as fractions as I do the math. Because the work, once again, when it comes to between fractions and ratios, the work is the same. Other than when I show my answer. I can have improper fractions if I need them. So how would I show this work? Well, if I notice that 8/12 are both even, then I would suggest, well, try reducing them. Extra thought. I apologize for jumping ahead. There is something that you're going to see on Moby Max, and you'll see it on the I-STEP test. I don't know about NWEA yet, so I want to introduce that real quick. We could have what is called vertical ratios or vertical ratio boxes. And the way that works is we take the same information that we have been doing horizontally, but we're going to do it vertically. It's not difficult. It's just one of the first couple times that you see it, you get a little confused on what you're doing. So just remember it's the same thing. It doesn't matter which way. It's just turning the box. This is a vertical ratio box. And I have a ratio of 6 to 2. And so I'm going to build going down. It works the exact same way of what we've been working on. I'm just multiplying 6 by 3 to get 18. Now if you don't know that, then you would jump out to the side and I would take my 18, my largest number, and I would divide it by my original ratio number, which is the 6, to know that I'm multiplying it by 3. Or here, I would know that that's multiplying 2 by 4. If I don't know, I would take my largest number, divide it by my second ratio number up there, and 8 divided by 2 is 4. So that's how I figure out what I'm multiplying by. Could reduce and do some division also if my original ratio was stuck in the middle. It's just going vertically instead of horizontally. But it tells me that if I'm multiplying this one by 3, vertically I do the same thing. I want to multiply my other one by 3. So that tells me I should have 2 times 3, which is 6. And over here we said, well, I multiplied 2 by 4 to get 8. So I'm going to multiply over here by 4. And 6 times 4 gives me 24. And this was 2 times 6, so 6 times 6, well, that would give me 36. So those look exactly the same as they do horizontally. I just fill in the numbers going vertically, still multiplying by the same number. So what do you think you would get on those? Give those a shot. Now, if you need to take a moment and pause the video, please do so. Then push play, and you'll see me solving the answers. As we look at that, I have a ratio of 1 to 4. 1 to 4, then I have to figure out, well, what am I multiplying this side by? And what am I multiplying this side by? And if it's on this side, I know I'm going back to my original ratio of 4. And if it's on this side, I'm going back to my original ratio number of 1. So when I work through it, then I know I'm going to multiply by 2, by 5, by 7. So if you didn't figure that part out, then go ahead and pause and then finish this up. If you're not finished, like I said, pause it and then come back to figure out the answers, because I just want to make sure that you know what you're doing. So I did multiply my 4 by 2 to get 8, so up here I have to multiply by my 2. And therefore I have 1 times 2, which is just 2. Well, to get this 5, I had to multiply my 1 by 5, so I have to multiply over here my 4 by 5, and 5 times 4 gives me 20. And then down here I had 4 times 7 for 28, and therefore I have to multiply over here by 7, and 7 times 1 is just 7. Are those the answers you got? I hope so. If not, then work on figuring out why. So now we're going back to these. I apologize for forgetting I was going to introduce that to you. So we're going to determine, we're going to decide, we're going to prove mathematically with work if these are equivalent ratios or not. So I'm going to look at my 8/12ths, and what I noticed about my 8/12ths is that they are both even, so I can reduce. And I want to see if that will help me. So if I reduce both of those, what can I reduce by? Well, I could reduce by 2's, or I could reduce by 4's. So let's try two different ones. If I reduce by 2's, then I get 8 divided by 2, which is 4, and 12 divided by 2, which is 6. Does that help me solve for that one? Well, it really doesn't match up. So let's see what else I can reduce by. I could continue to work forward and reduce that one by 2 also, since they're both evens, or I could go back and reduce by one bigger number than 2. And the bigger number that they can both be reduced by would be 4's. So 8 divided by 4 is 2, and 8 divided by 4 is 3. So are those equivalent one to another? I reduce the 8/12ths and see that it is 2/3, my original ratio over here, so I would say yes, they are indeed equivalent one to another. So now I have 8/10ths and 6/10ths for number 15. And 8/10ths and 6/10ths, they're both even as well. So I'm going to reduce them down as far as I can. Now, some of you are already saying no. And I agree with you, but we're going to do the work and just reduce it just so we know how it would work. If I reduce both of them by 2's, because they are indeed even, then I know I have 8 divided by 2, which is 4, and 10 divided by 2, which is 5. And I'd have 6 divided by 2, which is 3, and 10 divided by 2, which is 5. Now here's the thing that some of you said no from the very beginning, because you saw, well, I have the same denominator and my numerators are different. So those cannot be equivalent. And when I reduce them, I get the same denominator, and still they're not the same numerators. So you're correct. They cannot be equivalent. So I'd like you to take a moment, and I would like you to work 16 and 17. Pause the video now, work through those problems, and then restart it so you can see us work them out. So on number 16, you should end up with a yes, and for number 17, you should end up with a no. When I took 16 and I saw 16/60ths, I knew the 4 went into both of those. So if I reduce by 2 and then reduce by 2, I would still be reducing by 4, and I would still get the same fraction. So there are more than one way that I can reduce them. But if I wanted to do it in one step, I reduce both by 4s, and 4 does go into 16 4 times. And 4 does go into 60 15 times. And therefore, my original ratio down here as my second one was 4/15. So yes, indeed, they are equivalent ratios. Now, number 17, I had 3/14, and I can't reduce 3/14, and this is a larger one here. So I decided to multiply 4. Now, I could have reduced 8/28 if I wanted to, and compared it to 3/14. But I just went ahead and I multiplied with 3/14. And with 3/14, and I multiplied by 2's to get that same denominator of 28. 3 times 2 is 6. 14 times 2 is 28. 6 28s and 8 28s. No, indeed, they are not equivalent ratios. So understanding our ratios, equivalent ratios, once again, just simply means we're talking about equal value ratios. And when they're equal value ratios, it doesn't matter how they look because I'm not going to reduce them. That's one of the biggest difference between fractions and ratios. When I'm finding a ratio, and it's an equivalent ratio, I know that it could be reduced, but I'm not going to because it's not a fraction. I'm comparing different things. And when I'm doing that, then I also know that I'm going to multiply or I'm going to divide to find my answers. So as we went through this, hopefully you kept up, and if you fell behind, please go back and rewatch it so you understand what we're talking about. These videos, once again, are there for you in class. They're there for you at home. You can use them at any time to go back and review that you need to. If you have any questions, then come back to the back of the class while I'm working with other people. If not, look at the board for your homework assignment.